Hello, in this video, I want to present to you about my project, which is Advanced Roadblock Automation System. For the project background of the Advanced Roadblock Automation System, we aims to enhance the efficiency police operation during the roadblock. We focus particularly on verifying compliance with the car window tinting regulation because they have major concern about the law enforcement in ensuring that every vehicle that pass through the roadblock need to pass the legal tint limit because excessive tinting can lead to some safety risks by reducing the visibilities of the drivers and can also prevent from the police officer to see the view inside the interior view of the car during the inspection. So for the problem statement, first one is time consuming. So by using the sensor, we can prevent some unnecessary traffic congestion, and they also have some human errors or subjective judgment, which can lead to inconsistent enforcement of the VLT limits. So these are the problem statement. So these are the three sensor selection and selection criteria. So the first one is criteria. First sensor is infrared sensor, and the second one is laser sensor, and the third one is UV light sensor. So for the sensing distance, the infrared sensors have the second highest, which is 100 mm to 4 meter, and the second sensor laser sensor from 0.1 meter to 10 meter, and sensor 3 5 centimeter to 50 centimeter. So move on to the sensing method. For the first sensor, it used polarized retroreflective, and the for the second sensor laser through beam, the third sensor UV light absorption, and the price here is $50 to 100 per unit for the infrared sensor, 200 to 500 per unit for the laser sensor, 20 to $50 per unit for this UV light sensor. So VLT accuracy for the infrared sensor, it's in a good condition, which is in a range of 20 to 70% VLT. And for the sensor number two, laser sensor, it's have a excellent, which is 5% to 100% VLT. And the third sensor is fair in like between 30% to 100% VLT. So what is the cons is for the first sensor is struggle with below 20% VLT, and for the second sensor is expensive and complex setup, and the third sensor is limited to UV filter detection. These are some datasheet link for you to check on the data sheet of the sensor that have chosen in the previous slide. So the recommended solution is E3ZR86, which is the infrared sensor, the first sensor. Why we choose E3ZR86? Because first is have a balanced performance, which is detects 20 to 100% VLT, which is covers JPG requirement, which is in Malaysia need to be more than 70%. And second is cost effective, is more cheaper, is 5 times cheaper and than the laser sensor, which is the most expensive sensor that we choose in the previous slide. Field ready means that it's compact in size, work in daylight, sensing method, and the sensing distance is good. Limitation is the below 20%, but that can be helped by backup of handheld meter for the police to use. But normally they didn't because the regulation already said that the car need to be more than 70%. So this is just extra knowledge for you to know. So for this slide is we talk about the strategies for experimental plan. and when to use, where to use, and test the sensor. So in the first picture, you can see that first picture is where there's some sensor test on the glass panel with a known VLT films. I recommend you to take an range from minimum, middle, and the maximum, which is in the picture is said that 30%, 50%, and 70%. Because but normally most of the officer will choose the 70%, because in JPJ regulation in Malaysia, the car need to exceed more than 70% VLT to pass. And it also said that it need to be controlled in a control lighting. So move on to the second picture, which is when to use and where to use. So when to use is when doing the roadblock. So but before that, we need to test. We need to put the sensor on the stand. I recommend 1 meter from the car windows to test for the world condition. Then if it works, then we can proceed to move on to the main event. So after we done the test, we follow through with the third picture, which is we also need to compare the sensor VLT accuracy with the handheld tin meter, because from this we can see that uh, which one is more reliable based on the VLT accuracy that we get from testing uh, every car that pass through. So due to this, we can uh, we can fix the problem that we have received from the police officer. So that's all. Thank you for your time, and thank you for listening to my presentation.